All right. Good morning, everybody. Thank you very much for being here. On behalf of Current and all of our panelists, thank you very much for being here for our third webinar in a series about accelerating the energy transition. My name is Alex Hodeling, and I lead sales at Line Vision. We have a very high quality presentation for you this morning, and we are all going to walk away knowing much more about how we can fully utilize dynamic line ratings for an optimized grid. Dynamic line ratings as a tool is receiving massive global attention around the world, and Europe, in many respects, is the leader in the field, although I will note that United States is gaining quite a bit of ground in the number of projects as well. My industry peers from Enpasaman, OTLM, and Heimdall are all members of Current as well, and we are all like-minded in that we see this year, 2021, as the year of dynamic line ratings, and we expect that it will continue to take off and fully deliver on the promise of a more optimized grid. And in a moment, I'm going to turn it over to Friedrich, who will share his thoughts on the current state of DLR. But first, a few logistics. We have a full agenda this morning, so each of our 7 speakers will have limited time to share their thoughts, but that's really by design because we want to make sure that we bring to you a wealth of perspectives and opinions about dynamic line ratings. But we invite that you all ask questions or share your thoughts in the Q&A functionality within Zoom. And should we not be able to answer those questions during this hour, we of course will follow up with everybody to make sure that you receive answers to your questions. Rena, next slide, please. Here's a list of speakers with whom you're all, I'm sure, familiar. These are all wonderful, very notable speakers within the field. You'll be hearing from each of them this morning. And keep in mind, this is growing, next slide please, Rena, on what Current is offering the market. This is, again, our third in a series of webinars. Hopefully you've been able to join the previous 2 webinars that were offered with very compelling topics as well. And at the end of this session, we will also announce our next in our series of webinars that will be coming up in a few weeks as well. So we look forward to that. With that, again, thank you. I'll now turn it over to Friedrich from Enpasaman, who will share his thoughts on DLR and some information about Current as well. Friedrich. And I think you're on mute, Friedrich.
Very good. Thanks, thanks, Alex. Good morning, everyone. So my name is Friedrich Vasseur. I wear 2 hats today. I'm both the CEO of Enpasaman, one of the DLR providers, and I'm also the vice chairman of Current Europe. So let me say a few words of introduction about who Current Europe is. Current is an association, a technology association, an industry association of technology providers who all share the common goal to efficiently develop the grid in line with Green Deal objectives and decarbonization objectives in general. So the members of Current want to promote those technology, those energy efficient technologies to all grid stakeholders. Utilities, of course, but also regulators and customers, so everybody who could potentially benefit from making the grid more efficient and greener. So amongst the various technologies that our members offer, DLR is certainly one of those key so-called enabling technologies represented by 4 providers within our industry association. So let me go back a little bit in history. DLR started about 20 years ago as research projects with various utilities around the world, mostly in the US and in Europe. And they took different technology approaches. It was very much technology centric at that time. Some using a direct method with sensors hooked on the lines, some others using model-based approaches. It took a long time. There were many false starts. Some of the early providers of technologies are not there anymore. Some of the early adopters are not there anymore either. But since about 10 years, we've seen an acceleration. And now it's really a mature technology, and it's evidenced by the number of public tenders that we have been seeing over the last, I would say, 2 or 3 years. So clearly, there's really an acceleration that we have seen recently, and we're no longer in those times when people were trying DLR on a trial and error basis almost. This has now really become a mainstream tool used by most advanced utilities around the world. So the key to that, I think, it falls in three categories. First of all, of course, the technology providers made sure that the technology is sound and robust and really works. So that's no longer, I don't think anybody questions the fact that technology, the DLR technology works or doesn't work. It does work, it's mature. But the second, also very important topic, and I'm sure we'll come back to that today, is the fact that it is now well integrated in the rest of the grid operation management systems. And that was a key part. And last but not least, we're starting to see, I would say at long last, more favorable regulatory environments, which push utilities, push grid management grid operators to adopt DLR as one of those tools that they have at their disposal. So we'll explore that landscape today, covering, of course, technical aspects with some technical experts, but equally important, also we're going to cover how DLR is deployed and integrated into the utilities operations, and for which use cases, because DLR, you know, as much as it's a fascinating technology, it doesn't serve all purposes, but it is very, very well geared to answer some key issues of our customers. So we have today a very impressive array of speakers who all have years of experience in that topic, who will bring different angles of views and shed different lights on how DLR is used, what DLR is, and how it is used by utilities. I'm very, very excited to hear what they have to say on this topic and to learn from the various stakeholders how they consider DLR to be part of the future grids of tomorrow once we, you know, in order to reach our decarbonization goals that we all want to achieve. So with that, let me turn to our next speaker, Uros, who will give us his angle of view on the progress of DLR in our space. Uros, over to you.
Oh yeah, thank you. Do you hear me?
We sure do.
Okay, thank you very much. Yes, thanks, Alex. Thanks to Frederick. I'm very glad to be here on behalf of ENTSO-E, and I'm representing Research, Development, and Innovation Committee in this organization. I'm the vice chair in this group, and yes, I was really glad to give my contribution into this exciting, important topic. I would like to start actually where Frederick already mentioned what is so important, what are the challenges of adoption of these technologies. I share with him everything what he says. So it's mature technology, we have it ready, and there is maybe just something missing to speed up the whole thing. We know that, and we are not hiding from that fact. But I think when we want to really grab and reach these goals of having these technologies ready and in full operation and deployed and in use, that's very important in the next 1, 2, 3, or 4, maximum 5 years. That should be the target. I think we should understand that DLR technology is sharing some hype and some destiny of all intelligent smart technologies. We should take this as a fact because we have to leverage on that, and all these technologies need and require extended learning. We have to learn about it because some people still underestimate the technology. They just think it works whatever you use in whatever circumstances. You have to be very aware what's important for this technology to give full results. And some people still a bit over exaggerate the complexity and all this stuff. So that's why the learning is so important. Use case was mentioned. Yes, it's much easier if you have a good use case in your environment, and it helps you boost all these things much faster. But what I would like to highlight even more is the mindset, the experimentation mindset of the people which should use this technology and final stage in the control rooms, in these control room environments. This, I think, is very important if we want to get out these benefits which have been already mentioned. So benefits which I see must be presented in the way that this is not an alternative to anything. This is a unique technology providing unique benefits. It creates special value. It's complementary to other possibilities and investment. It always brings added value to whatever your state of the system is and whatever your traditional line investments are. This is very important to understand. But when I go back into this experimentation environment, I think I should also mention what ENTSO-E is doing here and how we believe that research community can help pushing technologies forward. So we actually want that more TSOs create this workspace where full operational systems get into this experimentation stage, so that we bring people into some sort of demonstration environment. So this is now also the determination of ENTSO-E research community, that we do not want only push for low TRL and position paper work, but we want to create this kind of support to the TSOs that they will more easily establish such environments. And here is also the key that TSOs should share this experience, how they have created these environments and how they convince the people from the control rooms to go into a bit more experimentation. And I'm not talking about this highly sophisticated experimentation. I'm just talking about this minimum mindset which has to be created in these control rooms so that they more easily accept all these technologies. And I think this is the key, and ENTSO-E is now working on this. We will establish a special working group which will deal with this boosting of demonstration projects, environments, and all that stuff. And I think this can help a lot to reach the goals of the community as such, as a whole.
Uroš, thank you very much. And I wonder, you mentioned some very interesting points about the mindset. And I also liked what you said about how some of us might overestimate the complexity of the technology and implementing the technology. Do you think that the mindset is the chief limiting factor around implementing dynamic line rating? Is this just a mental hurdle we have to get over?
Well, I think, you know, it's like when you do big changes on everything where you want to make a big change, it should be a combination of things which fit together. Of course, it's also important that the technology works in a sort of seamless way. So I think people should not know at all that they're running the systems, which includes DLR. But it should be like Google style for me. You know, it should be something working in the background. But the awareness of what's going on should be, I think, there, and people should know what this technology is and what are the benefits. But yes, the mindset is part of the story, and I think it could help a lot to boost. But it's a combination. Yeah? So if you ask me what's the point, it's a combination.
I appreciate those comments, and I think to your other point about the need for demonstration, I think all of the DLR providers who are on this call recognize that often our TSO partners do look to those demonstrations, but I think it's examples that we can hear from our peer group here today as an example that should allow us to be able to stand on each other's shoulders and not have to recreate a demonstration project every single time. So thank you very much, Uroš. With that, I'll actually turn it over to Matthew from RTE, who can do just that. So talk about his experience implementing dynamic line rating, particularly for wind integration. And I'll turn it over to you, Matthew. Thank you very much.
Thanks a lot, Alex, and hi, everybody. As you said, I want to share with you my experience on RTE, the French TSO experience on DLR and the specific use case of wind integration. So since 2009, different DLR applications have been tested at RTE to determine the potential use of this technology. And from those pilot projects, the main use case identified in France is to allow the connection of wind power plants on the existing grid. This use case is based on the fact that there is a high correlation between wind and cooling effect. Moreover, in areas where there are a lot of wind power plants connected to the grid, the times when the line currents are very high, coincide with periods when wind power generation is at its peak. In the same time, when wind power generation is at its peak, wind is blowing on the conductor to help cooling them. This suggests that dynamic line rating will be very high at this moment. So yeah, on this slide, this phenomenon is illustrated by this graph, which represents the current, the static rating, and the dynamic line rating for the month of September 2017 for a specific line in France, a 63 kV line in France. This line is a specific case because it's a line for which the only use is to evacuate wind power generation. So saying that means that we are sure the line current only depends on wind power generation. And as we can see on this graph, when the current in orange is high, the ampacity, the dynamic line rating is also very high. So for this specific case, based on a one-year analysis, the use of dynamic ratings provided an additional 50% wind power capacity connection. So the first conclusion is that the use case of DLR for wind integration is really, really interesting. However, I want to share with you that there are still some challenges that we need to take up. Even if the correlation between line current and wind blowing on the conductor is good, it's not perfect. And we analyze this by two main reasons. The first one is that wind turbines may not be located exactly at the same place than the overhead line. According to that, times when line currents are very high coincide with periods when wind power generation is at its peak. But even if wind power generation is at its peak, it doesn't mean necessarily that wind is blowing on the conductor. The second reason is that most of the overhead lines are included in a meshed network. So even if the correlation between wind power generation and high current is real, it does not necessarily mean that low wind power generation implies low line current. So those two reasons may imply to have occasionally a dynamic line rating lower than the line current. And even if it does not challenge the economic benefits of DLR, because it's only few hours per year, for operators in the control room, it seems to be unacceptable for security reasons. So we imagine two solutions for this issue. The first one is to use forecast of DLR to anticipate those situations. For example, with accurate forecast, operators will have enough time to change the grid topology to avoid the line current to be superior to the dynamic line rating in real time. And the second solution is something we have tested at RTE, is an automatic curtailment of wind power generation. We develop a programmable logic controller which compare in real time the current in the line with the dynamic line rating and curtail the wind power generation if it's necessary. So the order of curtailment is sent from the SCADA of the TSO to the SCADA of the DSO and then directly to wind turbines. So in my opinion, and for RTE, this solution seems to be the best way and maybe the only way to consider a large-scale deployment of DLR in France. Thank you very much, everybody.
Great, thank you very much, Matthew. And I very much appreciate your comments, because I think that for many of us, the idea that the same wind that is cooling the conductor is also generating electrons. So there's that happy coincidence where DLR is a perfect fit. But I also recognize, to your excellent point, that depending on the heading of the line, that cooling effect might not be consistent across the line. So I think you bring a level of nuance to integrating wind that's important to consider. But it sounds to me as though there's still very much the benefit of incorporating wind using DLR far exceeds some of the challenges that might exist downstream Would you share in that opinion? Is that something that you think will allow RTE to continue to roll out DLR and increase its use of wind incorporation?
I think like Ruo say, we have to. There is a mindset for control room and for operators in control room to create demonstrator. But the next step after demonstrator is really a high step, and we need to share. I think all the utilities, as you say, need to share their experience to develop this mindset and to go further.
Excellent. Yes, I very much agree. So thank you very much. We're likely going to come back with some further questions, but right now I'd like to turn it over to Bálint, head of the High Voltage Laboratory at Budapest University, and talking about his experiences and another use case project that he can explain to the group. Bálint.
Thank you, Alex. Good morning, ladies and gentlemen. It's a pleasure and honor to be here in this nice group and try to give you a short overview on behalf of the Budapest Technical University. Next slide, please. So my title originally is the DLR to release the cross-border trade capacity to meet the 70% rule. Next slide, please. But first, however, in the previous presenters originally or already make a nice and good overview about the DLR. However, if we see the DLR in the first part and in the right side, the real-time monitoring of the overhead line, which is the main achieve and the main advantage of the DLR things. However, there are different models. Some of the models are using these real-time monitoring systems. Some of them are just using weather data, as we will hear these kind of solution later on from other presenters. What of the main goal, the main achieve is increase the system stability. And based on our research, which is about 10 years before started with an FP7 project, namely BESPAS. Then after we continued with several other international projects supported by EU and funded by EU, like FlexiTranstor or the FARCROSS project that I will show you later on. Based on these research that we did mainly in Europe with different distribution system operators and also transmission system operators, we see that the increased transfer capacity can be up to 20 to 30% in the 95% of the time. As you can see in the right side, there is the conventional line rating, and in a relatively shorter time of period, you can achieve a much higher ampacity using the dynamic line rating. Going back to the original title of my presentation, which is the 70% target. What is it about? It's coming from the clean energy package, which says the minimum capacity margin available for cross-zonal trade, MAZCT, is the minimum 70% target. If you see our one of the last reports made by the Agency for the Cooperation of Energy Regulators, shortly ACER, in these nice reports, they highlight that from the beginning of 2020, the TSO should focus to achieve the 70% target. And it's a big goal for them, how to achieve. And as an example, these reports also highlight the dynamic line rating can be a solution. So concentrating to the cross-border benefits, as you could see in the slide, how can the DLR solve this problem? Solving because it can give a solution for increasing the export-import transport. So this is what the 70% target is looking for. So solving the bottleneck, which is in the first line. Several other benefits from the cross-border point of view, like lower energy prices or a higher social welfare, less redispatching. So if you can achieve a higher capacity, if you can go through a higher capacity on the same line, can it be a cross-border or can it be inside of your country? Then you need to have much less redispatching. There are also several nice reports all over the world that if you can avoid this redispatching just once, then the whole implementation, the whole cost of the implementation of the DLR system can be very, very easily, and just a couple of weeks or months time, come back the whole investment. What else we have? Integration of more renewable energy sources, as Frederick was also mentioned before, increase the energy security, more resilient system, or faster market coupling in internal energy market. Next slide, please. So this, after this short overview, I would like to show you a real example that we are working together with 6 other TSOs. Namely, the project is FARCross project, which was started in 2019 and going on for 4 years. It has several work packages as all other European projects. And the work package 5, which is related to the DLR and the health index demo for the overhead lines. Complex grid management technology for handling the cross-border transition line capacity related issues. We are doing the DLR in 4 different locations, 4 different countries, and 8 different overhead lines which are involved, namely Austria, Hungary, Croatia, and Greece. Altogether, 6 TSOs are involved with 4 cross-border lines and another 4 lines which are also bottleneck, but inside of the country and caused problems in the previous years. During the project, we are almost finished the first year, which means that the overhead lines are, the sensors are already installed into the overhead lines. These sensors are namely Imoto, Line Vision, and OTLM, which already was mentioned today as well. So well-known sensor manufacturers and also well-known partners involving different universities and research centers who are responsible for evaluate the different results and who are responsible for comparing the different sensors and also the different algorithms. For sure, we're also implementing the weather stations into the overhead line for those sections where the sensor can find. What is the main goals of the project? One is that to unify the sensors and test how they are working in the different conditions all over Europe, or let's say in the eastern and central part of Europe. Comparison of the sensor measurements continuously. So we are evaluating during the project. The first demo part is the 1.5 year, and the second one is another 1.5 year time. So we have enough time during the whole year. It can be an icing, it can be a really hot weather, and we can really compare with real local measurements as well. So not only just comparing the one test to another test, but also going on site and doing on-site measurements for getting the real sag of the line during that particular days. And also a complex grid management model, which is the outcome of this project, of this FARCross project, which not only just based on the sensor technology, but also we are developed earlier project, some artificial intelligence supported neural network calculation model that we are also working and using in FARCross project. So all to all, I think this is a very nice project, and we are really waiting for the outcome of it. And as it is a European one, so we really hope that other TSOs through ENTSO-E can also see what are the results, and then using these data, comparison of the different sectors and different technologies, they can also start and move forward, as Frederick mentioned in the beginning, that new tenders are coming out. So we really hope that this project can also help and support to achieve the 70% target and also to get new DLR project in Europe. Thank you so much.
Great, thank you very much, Balint. Irina, can you go back to the last slide for a moment, his first slide? Because I think one of the things that has struck me from your comments, Balint, but also from yours and Matthew, is if you look at the slide or the image on the upper right, I think many of us think about dynamic line rating and the promise of increased capacity, but it's been noted that the portion on the far right of the graph, where you see moments where the dynamic line rating might actually be below the static rating. I think that's a very important thing to note as well, because this isn't simply about more capacity. It's also about the safety and resilience of the system, making sure that for those moments where there isn't that available capacity, that as operators, we are aware of that as well. And I think that's just an important point to note, because really this is looking at the system at large, and safety is a component of that as well. But Balint, I come back to you. You've designed, I know, many tenders, many projects, and we're fully involved in the FARCross project. But I'm asking you just to think for a moment, if you could design the next project, your ideal project across Europe, with no constraints, what's the ideal project for you and your team, if you could design it?
It's a nice question. Related to DLR or related to whatever? This is the topic.
Yeah, just take out everything and just say this is what's most interesting.
We have some idea definitely how we will move forward. And as I mentioned, this is the third DLR project that we are involved. Definitely, I think the future is the DLR, how we can involve, but based on the sensor and smart technology, if we see and try to compare, for example, substations or generators with overhead line, in that situation, overhead line a little bit far behind. So if we see, for example, substations, or most of the new renovations, after renovations, and most of the new devices containing some smart devices, if we see and compare it with overhead line, we are still using the same devices, same insulator, same type of overhead line, conductor, and so on, without so much smart technology. So I think the near future is to combine these, let's call health index or asset management more deeply in overhead line section as well. And I think if we see SIGRE or if we see IEEE, the different working groups are moving forward into this situation. So from my prospect and working together with several companies like Ampesimon, we are concentrating to moving forward some nice asset management system and build up a complex Europe system into this point of view. And definitely we need sensors, and definitely DLR sensor and DLR technology can be one of the main input data.
Great. Yeah, I like it. Thank you very much. And you win the award for the most impressive background, by the way, Valant.
Thanks, appreciate it.
I love it. And also several people have mentioned, and I'll turn it over to Janko now, really that next step for taking dynamic ratings beyond the experiment or the demonstration phase and actually implementing this into SCADA and EMS systems. And that really is something that all of us need to pay attention to. And unfortunately, we have Janko here who has led us in that experience. So I'll now turn it over to you to share your experiences.
Okay, thank you, Alex. Next slide, please. First of all, my name is Janko Kuzmac. I work for ELES, which is the TSO in Slovenia. And today I'm going to explain you how we integrated DLR in our SCADA EMS and how we use those information in power system operation. Next slide, please. First of all, I would like to give you very brief information about our dynamic line rating system. Basically, it is a part of a larger dynamic rating system we call SUMO, which has, besides dynamic line rating, also the dynamic line de-icing module and dynamic power transformer rating. Next. Our DLR uses indirect method, which means that we use weather data to calculate the thermal current. Next. And we perform DLR for each and every span of the line. And here we have a graph showing one day in 2020, July, and shows the temperatures and the bottleneck spans for the 24 hours. And we may see that 69 of 123 spans were limiting spans for that day, which means that in advance you cannot rule out which spans are potential bottlenecks and which are not. And the fourth thing I would like to say next is that we use SUMO in operation since 2016, and currently we process 31 power lines. Next, please. Why DLR must be integrated in SCADA EMS? Because SCADA EMS is the foremost important operator's tool, as it is the main interface to the power system. Next. And current carrying capacity is one of the essential information of the element and represents somehow a cornerstone of the transmission system. And next, changing the cornerstone is a delicate job and should be performed with great care. Next, please. So straight to the point. we exchange between the dynamic line rating system and SCADA EMS the following information. We call it also a triplet, which is dynamic thermal current, conductor temperature, and maximal time in case of overcurrent. And in the opposite direction, we send overhead line current. However, next, to calculate the result triplet, we need lots of data like line and conductor properties and of course weather data. And weather data, next, it is processed from mesoscale weather model data and from measurements that are performed on the towers of our power line. And all this information is processed to get information on a microscale level, which is 100 by 100 meters. Next, please. Now, regarding the integration concept, the operational limit, which was introduced in our SCADA system, was invented just for this purpose, to integrate dynamic thermal values from DLR. And it may reach either static or dynamic or limited dynamic. Once the operator engages the use of the dynamic limit, the operational limit equals the dynamic value until it reaches the maximum allowed thermal current for that line. As next, and now if we go to the next slide, we will see how comparison for two different days. One is winter date, the snapshot was taken a few days ago, and one is summer day last July. As you can see from this image, if we take the winter day, we see that the dynamic value was 1211 amperes, but as it is limited to the 1200 amperes, the operational limit is 1200 amperes. I would like to mention also that a static value for this power line is 960 amperes. This is important to understand how we use already mentioned today low values which happen during the summer day, and that day we calculated for that particular moment 914 amperes, which is below the static value, but this value went into operation as operational limit to maintain the safety of operation of this power line. Next, please. And yes, LS is using conductor temperature measurements. We use those measurements not in the DLR process itself, but in controlling how the DLR process performs. And we use those information for three purposes. The first is we use conductor temperature to issue warnings and alarms to the operator within the SCADA system. We use it for evaluation of how good DLR algorithm performs. Of course, we need also weather station at that location. And the third use is the evaluation of weather estimation and forecast module performance. And with this, I will conclude my presentation. Thank you for your attention.
Well, thank you very much. A very interesting presentation. And from a technical standpoint, clearly you're very advanced, your team is very advanced in terms of the implementation of this. I also wonder from an organizational standpoint, for those who are on the line who have perhaps already worked with a dynamic line rating project or are anticipating this year investigating dynamic line rating, the people within your organization, the roles within your organization, who have you found needs to be involved in bringing the integration into the SCADA system to bear? Who are the people within an organization that need to be involved?
Alex, this is a very good question because many people were involved in this process, but we started in a control room. We found a representative of the operator who was able to make their wishes and expectations clear. Then we took a solution architect who drew how this should be done. Then we took a OT communication engineer who did the data exchange. Then we needed a SCADA expert who wrote the application, EMS expert who integrated these values into security analysis. And at the end, there was engineer who is responsible for writing the operation manual. And this was basically it. What is important that also other divisions or departments from Alice took place in this operation just to keep the responsibility basically regarding the correct data that are involved in this operation.
Great. I could ask you 10 more questions about that, but I think that's excellent, and I think very good for all of us on the line to hear, because it sounded like a very organized approach that we can all take to bring this to bear. That's excellent. So far this morning, we've heard about the current state of the technology. We've heard about projects, and we've heard about how to integrate this, which is great. But then the natural next question becomes, what's the benefit? What is the value of incorporating dynamic ratings into your system? And with that, I'll turn it over to Victor, who is going to talk about the financial outcomes of reducing congestion, which I think, again, is a big part of the reason why we do this and why we're here talking about this today. Victor.
Hello, everyone. Yes, so I'm working for ILIA, the Belgian TSO, and we have been working with Ambassimon since a long time. And so I'll try to attempt to explain indeed what kind of benefit, financial direct benefits you can tap from this technology. Next slide, please. Yeah. So directly here you can see that we are using direct measurement. Ambassimon technology is a small box you have to install on the line. For ILIA, we have about 150 boxes installed, and which amount for a total of about 30 lines. Most of those lines are 400 kV lines, so the backbone of the grid. And those are directly, this is a snapshot of the SCADA system of ILIA. And what is in yellow is actually the dynamic values, and this is fully trusted. I mean, those values are replacing live the static rating, so meaning that ILIA is making a full commitment, trusting those values live. Next slide, please. So I will be very brief here, but this was a long story. As introduced in this today, this is a mature technology today, but 10 years ago it was more prototyping and so on, and we were working since then already with the Ambassimon. And the big moment was in 2014, where we have a first rollout of a dozen lines. And then we quickly scaled up with the implementation of a forecast to be able to increase the capacity in advance, meaning that we were able in 2016 to increase capacities before the market coupling, meaning that the day-ahead market capacity was using increased capacities thanks to dynamic line ratings. Bringing a a big value to the European exchanges. Belgium is in the middle of big players, namely Germany, France, UK, and so increasing capacities of Belgian lines is actually increasing the exchanges capacities of all the neighboring countries too. So that was a big challenge, and we were, I think, one of the first to do this. And now it's a mature technology also within ILIA, so it's a standard. We don't question anymore the use, and we try to, it's a reflex we have now to systematically think about impassment in our grid development. Next slide, please. So this is just a picture of Belgium. You see the backbone here, the 400 kV lines. In purple, you see the lines equipped with impassment, meaning we have been equipping mostly all lines to allow big transit between the Netherlands and France. And yeah, Belgium is a tiny country within big players. So we can consider this backbone as actually one big tie line. So it was really important to equip most of the lines. Another interesting fact is in blue, you see 4 lines that were equipped with impassment, and we removed the modules because we have now HTLS conductor. HTLS conductor is really a nice technology. It's the future, I think, for most of us. ILIA will upgrade all its grid with this technology. This is already planned, but it takes a long time and massive outages, tremendous outages. Those 4 lines were equipped in the span of 4 years, and during those 4 years, we had one of the line out of service, mostly all the time. And that was a big challenge, of course. And so we decided to install the dynamic line rating before starting those pharaonic works. And that was really a life-saving strategy. So that's also a nice example of how to use this technology for a short period in time, but it was really valuable because we knew in advance that was a tricky period. Of course, when you install HTLS conductor, you are displacing the bottlenecks, and so the next you have always a nice candidate to install impassment. So here we see in red the next installation, which will happen this year, and so we have always a candidate. So we will be using the technology for some years in the future too. Next slide, please. And now about the financial benefit you could hope to tap. It's really a tricky question because we're speaking about avoided cost. So you avoid a tricky situation by increasing the capacity. So actually a situation which would have led to massive cost is avoided. And so sometimes you are not even aware that there were a tricky situation, because as I mentioned, we are trusting fully the value of impassment in our SCADA system, meaning that the dispatcher doesn't even know if we're using these capacities, and it's really important to have this extra capacity or not. And so what we can only say is that for this specific example here, it was the coastal area in Belgium 5 years ago. We installed this on a 150 kV line, so a lower grid part, because it was a story that we all know. We installed a lot of wind turbine before increasing the grid, because increasing the grid takes a lot of years, while installing some wind farms might be really quick. And so we had this situation for some years where we had a structurally weak grid, and we had always this situation when there were too much wind. We had to reduce some power plants in the area, and the cost was typically 40 euro the megawatt hour. This is really an idea of the price, but that's the kind of price you have to face, and so it can quickly be really high and be a return on your investment. Those prices are faced by the TSO, and so it's a direct financial benefit for the TSO itself. of course, when you go to international redispatching on the backbone lines and so on, the price is really, really high. We don't speak about 40 euro the megawatt hour, but be really more expensive. It might be $500,000 a day when you have a problem. So you can quickly find your investment back. Of course, it's a matter of chance. It might be that you install an Passiment on a line, and by chance you don't have any problem for years. So that's for the better, but so you cannot really anticipate what will happen on the grid. But it's also kind of a warranty that in case of such situation, you have a solution.
So Victor, if I may, that's an interesting point that you just made, that some of the financial outcomes are seen once the ratings are being used. What advice or recommendations would you give to those of us on the line who, or on the call, I suppose I should say, who are interested in this, but they need to make a business case within their TSO, and to do that, they need to demonstrate positive financial outcomes in advance of a project. Given that you've gone before many of us, which is wonderful, what advice would you give for us to make that case within our TSOs?
Yes, that's a good question. We have been struggling to defend this internally also before. Now we have seen that the benefit is there, so we are not anymore so much challenged about the benefits. So we don't have this question internally anymore, but the best way to do it is actually to work with your grid development department. So the department building the grid for the future 5 years, 10 years. And they probably do a lot of calculations. At Elia, at least, they do a massive amount of calculations. So they might see that in some situation, a specific line is overloaded. And you always have the question, should I increase structurally my grid, or should I use a temporary solution and a Passiment sometimes solution? So you might detect in advance where is the bottleneck and where are the lines heavily loaded. And you can also, we have this now internally, when we see in the calculation of grid development, we see a specific line with an average high load, even when sometimes it's manageable, just under the static rating, we might consider still to install Passiment, because you never know what will happen 5 years later. And so when you're too close to the static rating in your calculation, it's a good advice to consider Passiment. Of course, to draw a line and how many million of 1,000 euro I will earn in how many years, that's practically impossible, because we're all working with statistical with scenarios, and we don't know what the future will be. But you have a lot of information from your grid development department to use and to make a case, I think.
That's great.
So that's my, yeah. And here, I think it's good to see one example of the lines. The HTLS works on a specific line. As I said, we had a tremendous outage of 6 months, and here I see the data of 3 months' time, where we had an outage, and the parallel line was heavily loaded. And I've computed here the loss of so it's a line between France and Belgium, and I computed the load that this line would have seen after the loss of another tie line between France and Belgium. So it's a kind of a computation, and so this shows the flows after incident. But of course, all TSO have to respect this N-1 criteria. The loss of any element should not create any problem on the grid. Certainly on tie lines, where you could have a cascading effect and massive problems. Here we see in this graph that a portion of the time, but quite important, you have the load above 100%, which means you had a problem. You are above the static rating, and nonetheless, we've been through this. We allowed this, so it means that during this period, apparently, we had an increased capacity. If not, it would have been impossible to reach those levels. We would have done redispatching, counter trading, whatever, but we would have found a solution. And when we see of this, yeah, it's 150 hours during 3 months' time on one specific line. We had really those problems solved freely, so it doesn't cost a dime, and we could exchange those flux without any problem. So I don't have a euro after that, but it shows that it was really profitable. Yeah.
I appreciate that. And I like how you brought up N-1 as well, because as we start thinking about ratings, it's not just individual lines, it's the grid, and it's the cross-border effects like Balint mentioned, of course, but it's also thinking within each TSO's individual grid. So thank you. And with that, I'll turn it over to Georgios, who is going to address that point. So how we can think about incorporating dynamic ratings across the grid. Georgios.
Hi. So thank you. I think it was a great introduction indeed from Victor, because let's say I bring it back to the point of the grid planning. I'm the last in the row, but I think this indeed a big process that we are going now in order to understand what would be the benefits from using a dynamic line rating and introducing this in our long-term scenario planning. I'm working for Elia Grid International, and here I can present work that is done in the grid planning processes at 50 Hertz here in Germany. Next slide. So an important point to keep in mind is we are, let's say, building the grids under the NOR principle. So network optimization is coming before reinforcement and expansion. And in this case, optimization, like dynamic line rating, is one of the major options on the optimization. So we first need to see whether with dynamic line rating, we could resolve some future problems and take this into account before we go for another option of building, let's say, new copper. Next. And practically, as an example, what we are doing complex calculation. You can see here we have normally a line. Next, where you can see typically after our calculations with future scenarios, we normally analyze very high penetration levels of renewables. We can see that we see situations with the static line limit will be breached. And next. And here now what we wanted to do is actually introduce a new layer of information, which is the ampacity. So what would be the real, let's say, the ampacity of the line, including the local conditions. And this was, let's say, the key challenge in order for us to understand do we take a good investment decision, or could we postpone the investment, and what could be the benefit of its case? There has been a lot of, let's say, we do a lot of analysis. Next. And we tried also to let's say, find a way to reproduce this in order to have a kind of like a decision-making process. So you can see on the left, let's say, traditional way of analyzing this. We have what we do, we map actually the line loading results. So the results of our complex power flow simulations with the ampacity results for the specific assets. And we create this kind of mapping as a scatter plot. And then if you see, we have the static limit, and then you can see directly which in a long period, like in 1 year of simulations, we analyze a lot of operational snapshots. We can see in which cases we can have the power flows being over the limit. And then what we do, you can see it simply, if we draw the diagonal in this case, the diagonal represents more or less the cases where the line loading is equal to the ampacity. So what is below the line is actually cases where you have where you have maybe next. So you can see what comes up is actually this triangle where we can see that what can be a gain from implementing a dynamic line rating. And then you still have, maybe next, you can see still this area will be the area where we will need to move to have a grid expansion measure or to take a redispatch. So we could estimate what would be, let's say, the costs of it. And finally, And this, I think, what maybe next, we see also exactly what was mentioned also before. We may have situations where we have threats. So we may find out cases where the static limit, where the ampacity is below the static limit. And so what we are doing, I mean, this is just an illustratory example, is that we are trying to scan, to use this way to scan all the main assets in the system in order to see in our future scenario how robust the decisions are, in order to see whether we should go indeed for expansion option, or we should think the incorporation of dynamic line rating. And maybe next. And having, I'm trying to be a bit quick here. The point is that it's quite a complex process. So we are we really think, as I said, the dynamic line rating should be incorporated. It's for us a cornerstone on our NOR principle. It is a very data-intensive, complex modeling process, as we need to take into account asset information, future power flow results on scenarios, and also to isolate the possible weather conditions, to correlate the weather conditions on the specific time and geography. And this is also where we see these complex effects where in the backbone, there is a lot of effects. It's not only, although we see scenarios of very high wind penetrations, in the grid, we see all these coming together. So for us, this is why we use also this mapping, is mainly because we can see everything happening. So we can still see how all these effects come together in one specific line, and what could be the benefit from application of a dynamic line rating. Of course, as I say, this is more of a scanning, because you need to really go to a detail that you can get only in the end in the operations. Here, we're just trying to let's say, make a good guess. But further, this, let's say, the points where there's a lot of discussions and a lot of analysis in 50 Hertz is that, of course, there's the steps afterwards. We are moving towards, let's say, more big changes in our grid, and we try to see how to increase the loading, and this, let's say, creates a chain of other aspects that need to be analyzed and taken into account. Impact on losses. Another big point on the reactive power demand. The reactive power demand we see increasing in the grid, and especially the dynamic, the changes in reactive power are things that we need to prepare our grid for, and further stability aspects. So this is, let's say, in the grid planning department, there's a lot of work now at 50 Hertz trying to analyze the next step, how we can, by implementing these technologies, we can make sure that the grid is secure. And finally, last but not least, looking at the specific asset, very important is also to analyze, and this is also again the work that is going on in 50 Hertz at the moment, analyzing the specific assets and how ready they are to take this higher loading. So that's all from my side. I try to be as quick as possible. So.
Thank you very much. I appreciate those comments. And you are in the privileged position of being last, so you will be leaving us with the last thing to consider. So my question for you is, what recommendations do you have for those of us who are perhaps just behind you in terms of implementing this, for overcoming hesitation from teams within your TSO of incorporating DLR into planning? What guidance would you give us for overcoming some of those hesitations?
I think that what we see in Germany, first of all, let's face it, I started on purpose from the NOR principle to say that we need to implement, to optimize, we need to be able to prove that our investment decisions are robust, because these technologies, we see that they bring a lot of benefits, and we need to make sure that we take the right decision. So I think for me, it is really important to start bringing that all colleagues start to understand that we need to be able to understand what can be the benefits. But as I said, it is also kind of like it brings a lot of a chain of changes, which we were also, I would say, it's are things that we find out one by one. So you take one decision and then you see, okay, but this affects something else, and I need to analyze also that. And this is, let's say, also in Germany, because we analyze very extreme scenarios. This is, let's say, things that we need to really be prepared, because these are major changes in the flows and the grid. But definitely, I think this is a way that we need to start thinking. This is the way that we start thinking on developing, on how do we develop the grids. Yeah.
Great. Well, thank you so much for those comments. And again, on behalf of Current and my peers within Current, thank you most importantly to our excellent speakers. I think this was a wonderful presentation. I know I learned a lot. I'm sure everyone else did as well. And I'd also like to thank our audience for showing up, because it shows a dedication to thinking critically about dynamic ratings and thinking about how they can play a role in helping optimize our grid. So thank you very much. I'd also like to draw your attention at the close to our next webinar, which will be on a very important topic as well, which is cybersecurity. And as we solidify a date for that, and another group of excellent speakers will be, of course, communicating with all of you, so we can hopefully see all of you there again. Thank you very much, and please enjoy the rest of your day. Thank you.